So 1.2, we're moving on in real numbers. And now that we've got these properties down, we're going to start adding and subtracting real numbers. So like I said, real numbers for our purposes right now are anything that are on a number line. So a number line would have 0 in the middle and move up here to all the positives. Oh, I wasn't counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then down below 0 would be all the negatives numbers. So 1, 2, 3, 4, -5 and -10. So in Canada, we're used to this because we're used to positive and negative temperatures. You can conceptualize this with earning and borrowing money um, if you have debts. And you can also sometimes like I kind of anthropomorphize numbers and think of it as like kind of like, positive and negative people. I don't know, I could get in trouble that way, but that's sometimes how I conceptualize it. So real numbers are positive and negative signs with integers, and let's use them now. So as you remember, integers were all the whole numbers, so no fractions, no decimals. And so in real numbers, we include all the integers, but we are also including all the things in between them. So real numbers are integers plus all the extras. And like I said, opposite to real numbers are imaginary numbers. And when we have some context for that, then we'll start talking about imaginary numbers. At this point, stretching you into letters is enough of a transition. Okay, so as a quick example, say I borrow 10 bucks from you and we could call that -10. I owe you $10. So then I pay you back $5. And so now I still have a debt of -5, right? You're adding and subtracting real numbers. You're taking into account whether it's a debt or a credit. So say I'm a little late to buy my lunch again and I bum another $10 off you. Well, now I'm down. My debt is -15, right? And when this is money, it makes a whole lot more sense to us. So say I realize I'm bumming money off you all the time for lunch and I'm going to pay you back $20. Oh, but I'm going to borrow 8 more. So listing it all out, you can see how you can start to add and subtract these real numbers, and I end up owing you $3. So a number line's often useful to visualize these. I've already drawn one at the top of the page here. And that's what we're going to practice doing with these is adding and subtracting these things on the number line. Oftentimes people have, maybe walked the number line back in grade school or tried to understand this various ways. And I just wanted to remind you that also you have a calculator. And so entering, adding, and subtracting into your calculator, no doubt is something that you've got down. But if you want to make something negative, like in this example right here, on your calculator, you have a positive negative button, and that'll make a number negative. It is different than the minus. The other button that some people have on their calculators looks like this. It has a negative in the brackets. And again, this makes a number negative. And so hopefully you have secured the calculator that you're going to use for your math upgrading courses, and you can get to know that calculator and know how to run it, because it's really a tremendous tool in your math education. So your textbook goes on and teaches you a few strategies to get the answer when your calculator's not working. And I think that sometimes we land somewhere in between different strategies. And so if you're comfortable with your calculator, that's fantastic. We're going to, just humor me hopefully for a short minute here on how your textbook goes through these ones. So we're going to start by adding real numbers that have the same sign. And the rule with this is keep the sign the same. So if I owe you $5 and I'm going to borrow another $10, you add those numbers together and it's still a debt, right? So the sum of two negatives is a negative, the sum of two positives is a positive, to say it in mathy talk. So everybody can do this one. 3 plus, or sorry, that's a 4. 4 plus 3 would be 7. You add the numbers and you keep the signs the same. This one, because they share that sign and we're adding them, the net result would be a -7. right? Those ones are pretty simple. They're pretty straightforward. You can practice using your calculator just to get the buttons down, not that you need it. But again, starting with one that you know the answers for is often a good place to start building your skills. Over here with good old fractions, and these ones at least are merciful because they do have common denominators. It would be cruel and unusual if I made you do more than that right now. So the thing is, I'm adding two numbers, two real numbers, with the same sign. So it says in the rules, add the numbers and keep the sign the same. So I've got 3 and 1 that I am adding. So that would be 4 over 2, because that's how fractions work, and I keep the sign the same. They were both debts, they were both negative, so my answer is negative. I would simplify my answer here to a -2. All good? One more. If I have two negative numbers, same denominator, so that's great. The rule is add the numbers, so I add the numerators, keep the denominators the same, and because they're both negatives, my answer is going to be negative. I would simplify this to a -3. All right, so the next part of your textbook talks about adding numbers with different signs. And so I'm going to do a few of these ones. You can use your calculator. I'll throw the answers up, but in class we can go through the solutions to these if you like. So what these ones say, because they have different signs, what we're supposed to do is subtract the numbers and then take the sign of the larger. So let's try that. So if I subtract these two numbers, they're different by 3. And the one that wins is the bigger number. So here, 6 is the bigger number. And because it's negative, my answer is going to be negative. Again, this is the way your textbook goes through it. And I've chosen to do it this way in the notes because sometimes it works for people when other strategies haven't. So your other strategies are conceptualizing on a number line or using your calculator. Okay, so D, with these ones, I have opposite signs. This is a +4. When there's nothing in front of a number, the thing that's not written or imagined there is a positive sign. So they're different signs, and I'm supposed to take the difference of these two numbers, so that would be a 4, and the larger number is going to win. And so because the 8 has a negative, my answer is negative. I'm going to save, oh, I'll do the fraction one. So with these ones, I've got different numbers. I've got a positive, or sorry, that's a negative and a positive. And so what I'm supposed to do is take the difference of the numerators. Mercifully, again, I've got the same denominator, so I know it's going to be over 3. So I'm taking the difference of these numbers, that would be 15. And the larger sign wins. So I'm comparing 1 to 16. Well, 16 is a larger and it's positive, so my answer is positive. You don't have to write it there, but you can if you like. And simplifying this, my answer would be a 5, or specifically a +5, which is what we don't write. We imagine that it's in. So for F and G, I'll throw the answers up here. You give them a go. And for H, I would encourage you to use your calculator on this one. I mean, you can do it without, but it's a good one that starts to make that tool maybe a little more relevant. And the key thing with your calculator is that the subtraction operation sign is different than the positive negative button, or if that's what your button is. So just practice using those options. So we're going to do some mixed examples. So far, we've talked about two different kinds of adding. So when their signs were the same or when their signs were different. So A, when we categorize this one, I've got different signs. So that told me to take the difference of the numbers. So that'd be a 9. And the larger value wins. It gets to keep the sign here. And so I'd get -9 there as an answer. The next one, I have signs that are the same. And so I know that I'm going to have a negative answer because they're both negative numbers and they're 15. You can see here that when we start to mix the examples, what was really simple and straightforward starts to get a little bit trickier. So give the last two a try. I'll throw the answers up. And if we need any explanation, we can do that. Again, it's about categorizing them and attacking them with a strategy. Okay, so moving on. So we've added numbers that had the same sign. We've had added numbers that had different signs, and now we're going to subtract real numbers. And your textbook suggests, all right, well, we've already gone through adding numbers. So why don't we rewrite subtraction problems as an addition problem and do what we've already been doing? So in this one, we can rewrite this one as an addition problem. It's the same thing as 15 plus a negative 7. And that's what this is trying to illustrate up here with the pattern, with the letters. And so now that we've got it rewritten, we've already done ones like this. Because they have opposite signs or different signs, we take the difference, so that would be an 8, and the sign of the larger number, so that would be a positive. And my answer is positive 8. With B, rewriting this, and you might not have needed to do it with that one. That was definitely an intuitive one. I always remember these from playing crib with my grandparents. I don't know if anybody else is a crib player. So B, getting on with that one, it's 5 plus a negative 13. And here we have opposite signs, so we take the difference of this, and we're then going to take the sign of the larger number. So I get a negative 8 because 13 is bigger than 5, and the difference of these numbers is 8. I'll do these ones quick while we're here. So this one, rewriting it as an addition problem, it would be a negative 5/6 plus a negative 7/6. And so they share a sign, so I add these together, so I'd get 12, but it's a negative 12. It's still over 6, and simplifying that, my answer would be a negative 2. One more, because we're here. Your calculator might work on this one, and honestly, you could just plug it in straight like this in your calculator, or you can follow the instructions of the textbook, and I'm going to do it like that, rewriting it as an addition question. Definitely overcomplicating it. And on my calculator, I get a negative 2.2. And you could do that one by hand too. Okay, so two negatives together like this make a positive. And I had somebody once who showed me something. They're like, yeah, every time I see that, I just turn it into a big old positive. I was like, wow, I've never seen it look like that. I would always rewrite it. So that's 7 plus 8. And I can do that way better than I can think through this double negative nonsense, right? And so my answer for 2 points, if you're a crib player, 15. With this one down here, again, I've turned it into an addition problem. They have opposite signs, so I take the difference of these, and I could do this one on my calculator as well. And so I'm going to rewrite it. I did it all scribbly here, but you could rewrite it like I did up there. And my answer is a negative 9. Down here, rewriting it because I have two negatives smack beside each other. That's the same as 3 plus 10. And that's a whole lot easier to calculate or compute. So my answer is 13. So sometimes we just get things really complicated looking, and simplifying is a skill that we'll be doing in math. Often, sometimes those are the instructions on the question, are to simplify, and we'll talk more and more about what that means. But this one, we could rewrite 1 minus minus 2 as an addition problem, and it's 1 plus 2. And you have to admit this is oodles simpler than that big nonsense. So it is important to rewrite things as an addition problem sometimes because it really does make them easier to understand.